Welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In the last module, we built a CI and CD pipeline for a Java web application project using Jenkins, Maven, and Apache Tomcat. In this module, you will get familiar with another important tool to manage our relational database schema versioning. This tool is called Sqitch. So let's get started. Any modern application needs to save and read data from a persistent medium. More often than not, this persistent medium is a relational database like MySQL, PostgreSQL, etc. These databases have been around for decades, but deploying and updating our databases in a consistent manner is not an easy task. In this module, we will try to solve this problem and guide you through the process of creating a CI/CD pipeline for database deployment. First, let's start with a review of our environment. Our database source code will be written as SQL script files and be stored in Git. We are using a Git repository hosted within Bitbucket. Our database platform of choice will be PostgreSQL. Here is a free and open source administration tool called PHP PG Admin, which we will use to manage our relational database. The idea here is that we will submit all our schema and source code changes from our database to our Git repository. Then we will create a Jenkins job to pull the latest source from our database Git repository and update our database with the changes in a consistent manner. It may sound like a very simple and straightforward task, but anyone who's been in the software development and DevOps field for some amount of time will attest to the fact that managing source code for database changes and applying them consistently across multiple environments is very hard to do. For managing the schema of our relational databases in a consistent manner, we will use a popular versioning and source control management tool called Sqitch. Sqitch is a database change management framework which can help us manage our database changes in a consistent manner. It supports scenarios where multiple developers on the development team are checking in changes simultaneously in an agile fashion. Sqitch keeps track of all these changes and is able to apply them to target database environments. Sqitch supports various database engines like PostgreSQL, SQLite, Oracle, MySQL, etc. The actual usage of Sqitch is very similar to working with a regular database management tool like Git or Subversion. Here are some of the core commands which Sqitch supports. Sqitch init project name. This initializes the Sqitch project and the required files and directory structure for our Sqitch project. Each Sqitch project consists of the following files and folders. Sqitch.conf. This is the configuration file for the project and contains settings like information about the target database, etc. Sqitch.plan. This file keeps track of all the changes and respective sequence of the database's changes. Deploy. This folder contains SQL scripts which will deploy the changes to the target database. Revert. This folder contains SQL scripts which will revert the changes in case of any errors or issues. Verify. This folder contains SQL scripts which will verify whether the applied changes were deployed successfully or not. In order to create a database change in a project, we can use the command sqitch add change name, and Sqitch will initialize boilerplate SQL scripts in the respective folders. It will also update the plan file with the new change. Once created, the developers are responsible for adding detailed code changes to the boilerplate files and ultimately pushing all these changes to the source control repository. That was a quick overview of Sqitch. To download the latest version of Sqitch, you can go to http://sqitch.org. You can also install Sqitch via Linux package managers. We have already installed Sqitch on our system and initialized this project called db_test. Let's review the code for our project now. Here's our sqitch.conf file. Sqitch supports a number of options and settings in this file, but as you can see, most of the options are commented out using the hash symbol. This is very similar to bash file format. These settings which have been commented out will be assigned the default values by the Sqitch engine. So Sqitch makes it quite easy for us to get started. The setting which is available is engine, and the value for this is PG. This signifies that Sqitch should be able to use PostgreSQL as the relational database engine. The next important file is the sqitch.plan. This plan file tells Sqitch engine about what commits have been made into our Sqitch project repository, their respective sequence, dependencies between the commits, etc. For instance, we see here there are 2 commits in the order listed here in the plan. So let's keep these commits and the sequence in mind. First schema, and then video. Now let's review some SQL script files. In our deploy folder, we have 2 files right now, schema.sql and video.sql. Let's review the code in schema.sql. We can see this code creates a schema called tutorial in our PostgreSQL database. In Video SQL, we can see the script creates a table called tutorial.video with 3 columns. Subject, which is a string-based column and is the primary key, comment, and timestamp. Basically, when we run Sqitch to deploy the project, it will look up the plan as per the sequence. First it will run the schema commit, and then the video commit. In other words, this project will create a schema called tutorial, and then it will create a table called video in that schema. So you see, Sqitch manages all the complexity in a rather simple manner. And in doing so, it provides very familiar processes and paradigms to developers to manage their databases. Sqitch not only allows us to deploy our changes, but it also has inbuilt mechanisms to verify and revert the changes in case something goes wrong. This happens via the scripts in revert and verify folders. Let's review them now. In this revert folder, we will see there are corresponding revert scripts to each commit in our Sqitch plan, that is, schema and video. This schema revert file will simply drop the schema our deploy script may create in the target database. Similarly, in Video SQL, it will drop the table tutorial which may have been created by the deploy video.sql script. Now let's move on to the verify scripts. What you can see here is a very clever way to verify the existence of schema. We are selecting the count of schemas named tutorial and dividing 1 with that number. If the schema exists, this count function will simply return an answer of 1, which will be divided by 1. Hence, the script should yield the final result of 1 divided by 1. But if the schema does not exist, the count will return 0. And attempting to divide 1 by 0, it will cause a divide by 0 error. Thus, this verify script will flag the problem in an elegant manner. Similarly for our video table, we are executing an SQL script to select all the columns from our video table, but notice here the where clause is false. Basically, here we do not intend to read any data from the table whatsoever, but we want PostgreSQL to verify the existence of this table and make sure all these columns exist. If the table does not exist in the database or the table structure does not match the expected structure, then Postgres will raise an error and thus will serve the purpose of verification of this commit. So when our team, or any other team, works on the same database at the same time, They just need to add their comments to the Sqitch repository using the Sqitch commands. Sqitch will ensure everything is kept track of and managed well. In fact, many of the Sqitch commands are very similar to Git, so developers who are familiar with Git will feel right at home with Sqitch. Okay, after this whirlwind tour of Sqitch, let's switch back to Jenkins and start working on our CI/CD pipeline for our database. Let's move on to our Jenkins homepage. Here we will create a new item or new job for our CI/CD pipeline process. Let's name it db_source. And as usual, pick freestyle project for the project type. And click OK. Let's take care of the housekeeping first. We will keep the builds only for 4 days and keep the last 4 builds. Next comes our source code management. We will wire up our public Git repository here. We will get the URL from our Bitbucket repo from the overview section. Copy the URL and paste it in our Jenkins job definition. Let's also check delete workspace before build starts to ensure we have clean and consistent builds. Now let's configure build triggers for our job. This time, let's pick poll SCM so that Jenkins can watch our Git repo and trigger a new build when changes are pushed to the Git repo by our development team. This polling is implemented in a similar way as a cron job with Jenkins, such that after regular intervals, our Jenkins job will ask our Bitbucket repo, "Hey Git, are there any new source code changes available or not?" We are going to specify this cron type expression to check the SCM every 5 minutes. And if there are, our Jenkins will trigger a build for this project. But if it does not find any fresh commits, Jenkins will simply wait for the next interval before checking the SCM again. Now we need to start configuring the meat of our job, which are the build steps. This is the most important part of configuring our job. For this particular job, all we need is to execute a shell command. Unfortunately, there is no special plugin for Jenkins to use Sqitch. Not yet, anyway. Jenkins has a huge community of developers and enthusiasts supporting it and writing awesome plugins for it. It is just a matter of time before someone comes up with a kick-ass plugin for a kick-ass tool like Sqitch. If it strikes your interest, we encourage you to develop it and contribute back to the community. Anyway, the lack of plugin does not hinder us in the least. Since Sqitch can be executed from the command line, we can easily integrate it into our job using the shell command step. Let's keep in mind that when we use execute shell build step, this build step will be executed on our server as is, just as if we were executing the command on the native shell on our Jenkins machine. So in order to make sure that our shell command step can find the required commands and files for Sqitch, first we will change the current directory to the workspace directory. Notice this is an environment variable with a $sign. As we've reviewed earlier, Jenkins provides access to multiple environment variables which could be used anywhere within our job definition. We can click on this handy link to view the list of available variables. This is workspace environment variable. It gives us the full path of the workspace directory at runtime. And now let's review what a workspace is. For each job on Jenkins, Jenkins allocates a unique workspace directory. This is the directory where the code is checked out and builds activities take place. In most cases, we should let Jenkins manage this directory and its contents. But as we have seen in various job definitions that we created, it is a good practice to select an option to delete this workspace directory before a new build is triggered. This will ensure that the current build is clean and the files and artifacts from the previous build do not interfere with the current build. Since the workspace directory is where all the code will be copied to once our Jenkins job pulls it from our Git repo, we must switch to that directory while executing our shell commands. So let's add that as the first line in our shell script. cd $workspace. Next, we will execute our Sqitch command via shell command. The exact command is sqitch deploy db:/pg:/deploy at 192.168.0.103:5432 Let's review that command in detail. We are using the deploy option to run our Sqitch tool because we intend to deploy the database scripts to our database. Next, we are specifying that our database engine is going to be PostgreSQL. Next, we have our user information and the credentials needed for the user who has access to the database. Next is the IP and port of our database server. And finally, we have the database name. Please note that all this configuration could have been provided in sqitch.cnf as well, but we are using a command line parameter option to explicitly demonstrate how Sqitch wires everything together. Basically, we are running the deploy command for Sqitch and supplying the information about our target database. Sqitch will look for the plan and the commits in our Sqitch project. It will also query the current state of the database and determine whether there are any Delta scripts which need to be applied to the target database. If so, Sqitch will use the specific scripts from the deploy folder which match the Delta commits. And ultimately, Sqitch will run those scripts against the target database, bring the database at par with the current project commits, and save the versioning information in the database itself. Please note that while running the Sqitch command, we are using a PostgreSQL user who has the necessary privileges to create, update, delete database objects like tables, schemas, etc. Alright, our job configuration is done for now. Let's click Apply and save our job. We won't run this job yet because we also want to create a Jenkins pipeline for verification of our schema changes. We do need the build pipeline plugin before we can build our pipeline, so let's make sure it is installed. We will click on Manage Jenkins, then click on Manage Plugins, and then click on Available tab. We will search for Build Pipeline. Here is our Build Pipeline plugin. We will select it and install it without restart. Now Jenkins will automatically download the plugin and necessary dependencies and install our plugin. Okay, now our installation has completed successfully. Let's click on this Go Back to the Top Page link to get back to the Jenkins homepage. And now we can create our build pipeline view. We will click on this plus icon, and for our pipeline view, we will use the name db_tetranoodle. Click OK. Here let's configure the most important setting, which is the initial job, which will kick off this pipeline. In our case, that is the db_source job, which will actually deploy the changes to our database. We will also check some options to make our pipeline more informative. And now click on Apply and then OK. Here we are in our build pipeline. So why did we opt to create a build pipeline here? Because Sqitch allows us to verify the status of our database deployment. Once the database deployment executes via this build job, if there are any errors or issues detected, we can execute the revert command for Sqitch to roll back all the changes which were just applied to our database. Thus, this will ensure our database is always in a consistent state. To complete those steps for our pipeline, we will create a new job. This new job will be almost identical to the db_source job. We will call this new job db_verify. This new job will be pretty much identical to our db_source job. We will connect this job to our Bitbucket repository, and then add a similar shell command to execute our required commands. First, we will change the current directory to the workspace directory, and then add the Sqitch command. Here we will use the verify option for Sqitch to verify our deployment. As this verify command executes, Sqitch will execute the verify scripts from our Sqitch project and look for any errors. Now let's save this job. And next, let's make this job a part of the pipeline. We will go back to the configuration screen from our db_source job and scroll down to post-build actions. Here we will pick Build Other Projects and select db_verify project to wire it up in the pipeline. Let's save and get back to our pipeline view. In order to monitor the state of the schema and database, we have this PostgreSQL management tool called PHP pgadmin. We've already connected this to our target database, Tetranoodle. As we run our jobs, we will see what changes are applied to our database. We can see here, the only schema available in our current database is the default public schema. Now we will run our pipeline and observe how Sqitch works its magic and updates our database. Let's click on the Run icon to run our pipeline. Our first job, db_source, is running now. Behind the scenes, it is connecting to our database and running all the required scripts against it. Okay, great. Our first job has finished successfully, and now it has kicked off the second verify job. Excellent! The second job also completed successfully. We will disable auto refresh and head to our PHP pgadmin tool to review the database updates. We will refresh the schema by clicking on this refresh icon. As we can see in our database, a new schema has appeared called tutorial. Under this tutorial schema, we also have a new table called video. This video table structure matches exactly what we expected after applying the deployment SQL script from our source repository. As you can see, Sqitch and Jenkins made it pretty easy to build a sophisticated build and deployment pipeline for our relational databases. We can configure our Jenkins jobs to monitor our source control system and look for any new database changes coming from various team members. From there, Jenkins can apply the changes to our integration, staging, or production database environments. These pipelines can be integrated with other build and deployment pipelines which deploy the latest web application code, middle-tier code, and ensure that all layers of the system are in sync. The possibilities are endless here. Let's get back to our pipeline and review what happened. So we already saw both our jobs succeeded. Now let's check out the console output for our verification job by clicking on this console icon. Here is the latest commit information as well, and here we see the job completed successfully. So the first job ran the deploy command, and then this job ran Sqitch verify against our target database with the correct Sqitch project name. Before we wrap up this module on deploying database changes, let's discuss some environmental challenges you may face while using these tools together. One issue you may run into is that PostgreSQL may not allow your Jenkins machine to connect to the database, especially if they are deployed on separate machines, physical or virtual. By default, PostgreSQL is a secure database, and its default behavior is to listen for TCP IP connections only on the local loopback address localhost. So, to get around this problem, we will need to let Postgres allow connections from our Jenkins machine. To do that, we need to update the client authentication for our Postgres server. Client authentication is controlled by a configuration file, which traditionally is named pg_hba.conf and is stored in the database cluster's data directory. HBA stands for host-based authentication. So we will log on to our Postgres server and edit this file. And we will make sure that our trusted hosts are allowed connections to our database server. We can either use the host name or the IP address of our host machine to configure it as a trusted host. We can use either IPv4 or IPv6 IP addresses here. More detailed documentation about this file can be found online within the Postgres documentation archive. After we modify this file and allow the required connections, we will save this file and exit. Please do remember to restart your database server for these settings to take effect. The next issue you may encounter is your firewall, or on a Linux system, a security module like SE Linux. To enable connections from our Jenkins machine, you will need to configure appropriate IP and ports to be allowed the connection. Once again, for convenience, in our case, we have simply disabled our firewall by editing this file, /etc/sysconfig/SE Linux. Here we have changed the SE Linux to disabled and SE Linux type to targeted. This will be enough for you to disable your firewall, and it may really end up saving you some time while trying to connect to your database server. Once again, this quick security configuration is only for testing and demo purposes. Please do not follow these conventions for production environments, and consult a security expert for proper configuration of your servers. We also suggest that you install PHP PG admin on your database server. It is a pretty simple and easy to use web-based administration tool. You can get more information about this handy tool from their website, http://phppgadmin.sourceforge.net. You can also install phpgadmin using yum install. Please do not forget to install the HTTPD service as well, because php-pgadmin is a web-based tool. After installing the tool, you can access it via your web browser, just like any other web application. Let's recap what you learned in this module. First, you got an introduction to Sqitch framework. Next, we built a Jenkins job and updated our database schema using this Jenkins job. After that, we also discussed some tips and tricks which we need to keep in mind while working with relational databases in a DevOps environment.